The light show of Jupiter's dark side is something you won't forget anytime soon, and NASA is shocked by it. Only Jupiter's dayside can be seen from Earth or with the Hubble Space Telescope. The nightside aurora can only be seen by spacecraft in orbit around Jupiter, such as NASA's Juno mission. Anyone who has traveled to the Arctic regions of Norway or Canada has likely been awed by the sky's dazzling curtains of light. The auroras seen on Earth are beautiful, but aren't the best in the universe. Because its magnetic field is 20 times stronger than Earth's, Jupiter boasts the brightest auroras in the solar system. In addition, its field funnels charged particles towards Earth's poles, producing brilliant auroras across the electromagnetic spectrum. Compared to the auroras we experience here on Earth, Jupiter's are just breathtaking. Jupiter's auroras have been studied for decades with the Hubble Space Telescope, but new data from NASA's Juno mission shows that they may switch off at night, suggesting that this is a phenomenon that we previously missed. The auroras on Jupiter and Earth are powered in different ways. Solar wind causes the auroras that we see on Earth. However, the auroras on Jupiter are produced by a massive current powered by the abundant charged material inside Jupiter's magnetosphere, much of which is ejected by its volcanic moon. Since the sun has no impact on Jupiter's auroras, they should appear the same as those we see during the day. The planets each have unique auroral displays in the solar system. Auroral ovals, which are basically circular zones of auroral emission encircling a planet's magnetic poles, may be observed on both Earth and Venus. Only on Jupiter can you see polar auroras, which are caused by auroral emission within auroral ovals. The auroras of Jupiter must be examined thoroughly if we are to make sense of these fluctuations. Although the bulk of Jupiter's auroral ultraviolet light is filtered out by Earth's atmosphere, the Hubble Space Telescope gets a front row seat to the light show from outside our atmosphere. Because Jupiter's magnetic axis is not perpendicular to its rotation axis, the full show is frequently beyond Hubble's grasp. The aurora on its night side, which lasts for several hours over each 10-hour Jovian day, have eluded our detection so far. NASA's Juno spacecraft made only possible the first glimpses of Jupiter's auroras on both its day and night sides. The magnetic axis of Jupiter is tilted in relation to its rotation axis. When Jupiter spins, the auroras shift to the opposite side of the planet, rendering them invisible to a spectator on Earth for short durations. The visible and ultraviolet images of Jupiter were both derived from Hubble observations. Polar auroras were predicted to persist on Jupiter's dark side. Looking at Juno data from the dark side, however, a team led by Dr. Thomas Greathouse found that a portion of Jupiter's polar auroras really faded drastically. It's still unclear to scientists how the sun produces these auroras. Sunlight's catalytic effect suggests it may be more significant than previously appreciated. The auroras on Jupiter are caused by charged particles streaming through the planet's atmosphere, which are ionized by the sun's strong ultraviolet radiation during the day. This charged particle source is invisible throughout the night, which may explain Juno's unexpected finding. The Juno mission's extended lifespan until 2025 means it can keep digging into this riddle and find its source. It will also maintain its ability to capture stunning photographs of Jupiter's nocturnal display of planetary phenomena. And extreme auroras are not the only wonder near Jupiter. NASA research suggests there may be small lakes on Europa's frozen surface. Finding underground water sources in the outer solar system is essential to the hunt for alien life. Europa Clipper, a NASA mission, will explore Jupiter's icy moon, Europa. Experts disagree on whether or not a global ocean resides under the moon's frozen surface, but if it does exist, it may make the moon habitable. Europa has been shown to have liquid water, albeit its source is still a mystery. Based on Galileo's observations, astronomers have determined that the moon's frozen surface conceals vast salty liquid reserves at varying depths both on the surface and several miles below. In 2024, when NASA deploys the Europa Clipper to the moon for a thorough examination, scientists will have a better chance of identifying any underlying water. About 50 times throughout its orbit around Jupiter, the spacecraft will come within a few hundred kilometers of the moon's surface, offering enough chance to gather crucial scientific data. Subsurface lakes on Europa may have a different chemical composition and behave differently than we previously thought. Cryovolcanic activity on Europa is widely accepted as the cause of the moon's water vapor plumes. The Planetary Science Journal has been flooded with supportive material in recent years. Cryovolcanic activity is similar to flowing slushy ice rather than molten lava. Previous computer models have placed the origin of Europa's volcanic activity on the frozen surface and shallow lakes, but the authors of this research have instead zeroed in on the planet's deep global ocean. Elodie Lesage of NASA's Jet Propulsion Laboratory is certain that Europa Clipper will find subsurface water. Our research suggests that water plumes may grow at depths beyond those previously thought possible. In theory, the Europa Clipper might dive to a point on Europa where liquid water is present. Recent research reveals that Europa's 1,940-mile-wide ocean of saline water may be home to active volcanoes on the ocean floor. Hydrothermal systems, which such volcanoes may power, are thought to provide a rich source of chemical energy that possible life forms could use on Europa. According to the study's primary author, Marie Bonkova of the Charles University in Czech Republic, our results give fresh evidence that Europa's deep ocean may be a habitat appropriate for the origin of life. She elaborated, saying, Europa is one of the few planetary bodies that may have sustained volcanic activity for billions of years, and perhaps the only one beyond Earth that possesses vast water reserves and a long-lived source of energy. Bonkova and her co-workers recreated in great detail the stretching and bending of Europa's innards caused by Jupiter's enormous gravity. According to research, this kind of deformation produces fractional heat that prevents Europa's ocean from freezing over and may even partly melt the top layer of the rocky mantle of the moon. The new research implies that melting has been fueling seafloor volcanoes on Europa for most of its history and maybe up to the present day. Intense internal heat loads were discovered to be the most prevalent at Europa's poles, where volcanic activity is most likely to occur. Lesage's computer models may allow scientists investigating eruptions close to the surface to reach more precise conclusions about what lurks under the ice. Her models suggest that reservoirs are most likely to be found between 2.5 and 5 miles in height, where ice is the thinnest and coolest. Glaciers slow down by sleeping deep below the surface. These pockets of water might freeze and expand to the point that they break through the surrounding ice, triggering explosions, like a Coke when you leave it in the fridge. The remaining liquid looks like a pancake with small holes. Ice becomes more compact as water fills the area beneath the ice. Because of its pliability, you can confidently stroll across the ice without worrying about dropping or cracking anything. It would seem less like carbonated soda and more like a balloon if water were separated in this way. This discovery will aid researchers until the Europa Clipper mission in 2030. Using a European prototype radar, we'll scour the ocean and coastline for icebergs. According to Don Blankenship, head of the radar instrument team, this instability may be linked to plumes rising to the surface, like clouds form above bodies of water. The Europa Clipper has been updated to the point where it can do modern data processing. The scientific cameras record high-resolution color and stereoscopic photos of Europa, while the infrared camera and thermal emission imager looks for evidence of geological activity like cryovolcanism. UV spectrographs may be able to detect the UV light emitted by an eruption's plumes. Positivity for future astrobiological probes may be inferred from the success of missions like Europa Clipper. Interstellar astrobiology is an interdisciplinary study with the ultimate objective of finding intelligent life beyond Earth. The Europa Clipper's main mission is to find out whether life exists in the moon's deep seas. The answer to the question of whether Europa is habitable could shed light on the origins of life on Earth. Will the team find alien life near Jupiter? Share your thoughts in the comments section below. Also, don't forget to subscribe to our channel and hit the notification button to be notified when we upload. Thanks.